chapter number 5, which is functions and pointers. Now this makes the heart and brain of C. Very important topics. So whenever you want to do some work, the better is to divide it. When you divide some work, then say you have office. Now that office has some CEO. Now he doesn't look at everything. He has department for everything and he has managers for everything. Say a manager for catering, a manager for accounting, a manager for say softwares, a manager for some branding. All these, they report to CEO. So CEO doesn't do any work. So this is CEO is main here. In our C, CEO is main, and CEO allots the activities, and these they report. After completing the activity, they report. So what is a function? A function is nothing but a self-contained block of statements. These are just statements, but the statements, they do some work. They take some input, they give some output. Even if they don't take any input or output, they do some work which is of their own regime. That is, if you are billing, then accounting can be done by one function. So this C function is exactly like this. This is a main. How do you know that this is a function? In C or any other language, the function is when you have a name, say this is main, and followed by the round brackets. This round bracket says that it is a function, or you can say the parenthesis. Inside this, we have a function called message. This message is a function because it has a round bracket. Now this function is not getting anything. It is not even returning anything. So when you call this function, the control of the program goes here. It goes like this, and it goes inside this. This will be printed. So first of all, this will be printed, this line will be printed, and then this will be printed. So this is the output. So the main is a function. It is calling message. So main is the calling function and message is the called function. A function can be called number of times. Any number of times it can be called. So we have this function now, main. Now it is printing something and it is calling these three functions. First function, this is called the function calling. This is called the function definition. Why? Because we are actually putting these statements which needs to be executed when this function is going to be called. Similarly here, Brazil, and for the same, Argentina. So first of all, this line will be printed, then followed by this line. Then I am in Brazil and I am in Argentina. So this is how it is printed. And from this program, we just draw certain conclusion that C program at least contain one function, and that is the main. The main is the function which has to be there. And you can have C functions, various functions, number of functions, and it is the gateway is through main. The gateway is main. It begins with main. And there is no limit of functions. You can have any number of functions in C program, and the function is basically how you write in main, that will be called in that sequence. And after each function, again the function when it completes, it goes back to the main. So main actually runs all the function calls. So this main, as we see that there is no precedence of priorities, just the order. That means if you go to this main, you will have this printf, then followed by the function, and then you have this printf. So this is the order. First of all, this line will be called or printed, and this function will be called. So this line will be printed, and it is calling Brazil. So now it will go to Brazil, and this will be printed. It will call Argentina. Then Argentina will be, the content of Argentina will be printed, and then I am back in Italy because you have gone back to the main, and then you gone back to Italy, and then you finally go back to main. So this is how the control passes. Control process from the call function from the calling function to the called function. This is how it goes on, and till the time it reaches the end, and then it gets back to the main. So what we learned, let us summarize that. C program is the collection of one or more functions. Function gets called when the function name is followed by a semicolon. For example, this is a function name, and we have a parenthesis and we have a semicolon here. So this is how it gets called. So function is defined when the function name is followed by a pair of braces, and inside this we have set of statements which are the body of this function. So this is called the function definition. A function can be called from any other function. In fact, main, this can be called from some other function. So this is the message. Now this message is calling this main function, so it will be called. Actually, this is an indefinite loop. So main is calling message, message is again calling main, and this goes on and on and on. A function can be called by any number of times. It can be called number of times. This is function, message. This is called here. Now again you can call message, and you can have number of times. There is no limitation as such. The order in which the functions are defined, it doesn't matter. Only the things which matter is how they are being called. They are being called in the main function or the function which is calling them. First of all, this message function will be seen because it is here. This will be printed. After that, since message 2 is called after that, this will be printed. So the order can be like this. It can be jumbled up. A function can call itself. We call this as recursion. A function calling itself is called recursion. You cannot have a function definition inside a function. This is not correct. This is wrong. So you should avoid this because this will give you an error. So there are two types of function basically. The function which you make or I make, we call it as user defined function. But the functions which are there already provided by the library of the C and which are being prototyped in .h is the library functions already given to us. So this is how the categorization of function goes. So actually we have already a library of C, or in other programming language also they have library. So those functions which are already there, we can always use it by just including the .h. These are called the library function. Otherwise they are called as user defined function because we make. Why we use function? See, function is an elegant way to write a program. You cannot just write everything in the main. The two reasons why we use function is we don't write statements again and again. That means writing a statement again and again for doing a certain work. For example, you are trying to calculate the triangle area. Now this triangle area is calculated everywhere, say 10 times in your program. Why you want those statements to be redundant? You write those lines again and again and again, rather than just make a function which computes the area of triangle, and then you can just call this function. So instead of rewriting the code of section again and again, just write the code in a function. Then whenever you are tracking a function, tracking your program, because if everything is in one line, you will not be able to track it. So how to track it? Means if you have a function, then even if you do something wrong, there is a trouble, there is a problem, there is some debugging has to be done, then you have all the things. You know where control has gone and where the problem is. Now separating the code will make your program easier, understandable, and even easier to write. So what is the moral of the story here? Don't put entire logic in one function. There is cohesion and coupling. The modulation or the modular programming has to be something like that. These functions should do a separate work, and the function should not be connected by themselves. If two functions, three functions, they are connected, then there is no point in writing the functions separate. So there has to be a very less coupling and very high cohesion. Passing values between functions. Now whenever we are dealing with function, as I explained you earlier, we are passing some values, we are getting some result. So passing the value and getting the result, it is not always necessary, but that is why we make the function. This is the basic idea of the function. So see, this printf and scanf we have been using quite a lot now. But this printf and scanf, because they have a parenthesis here, and when we call them, we write a semicolon after that. So printf and scanf, these functions are functions which are already defined. So they take certain input or parameters, and depending upon the parameters which are being passed, they do certain work that is already defined in their .h and .lib. Okay. Say if we have this ABC, we have three variables. Now you want to calculate the sum. So this ABC can be passed in this function, and the sum can be returned. How? See, I'm just writing a program. This is sending and receiving the values between functions. So we have ABC. We take this value in ABC from the user. We pass it to ABC. This is cal sum. A and B and C are called. Means passed, and now this is being assigned to sum, and we print the sum. So what this cal sum is doing, cal sum is just taking the A value in X, B value in Y, and C value in Z, and this X, Y, Z is being defined as integer. We have an inside variable D. This D is simply taking the addition of this X, Y, Z, and it is returning the value. And then we can get, when it is going to return, then only we can assign it to the left hand side. Otherwise we cannot assign. And now printing the value. So this is how you put 10, 20, 30, you will get 60. So in this program, we need to see certain things. The function main, it is passing three variables ABC in the cal sum. So this cal sum is the function which is actually taking ABC, this ABC. So this is the function call, and this function call will return some value because the function is actually returning some value, and we are assigning it to some sum. And this is how the cal sum is being defined. We have XYZ here, and this XYZ types are defined in the second line. ABC are called the actual arguments because these are the arguments where we send the value. These are actual arguments. While the XYZ, which are in the function definition, these are going to take certain values. These are the formal values or formal arguments or formal parameters, right? So we can have ABC as here also XYZ is there. So you can have this as ABC also. There is no problem because the scope are different. One is another function, the other is another function. So scope are different. you can have A, B, C and X, Y, Z both as the same name. And there are two methods of declaring the formal arguments. First is this one. We have a function name and we have X, Y, Z. Now, rather than telling what data types X, Y, Z has, we are writing int X, Y, Z. So data type is being defined here itself. So that is why this way is called K and R method. This is called Kernighan and Ritchie method. One more method is ANSI method. In this, we are not taking two lines, but in one line only, we are giving the value, these variables also, and then also the type. So just putting it on one line is also acceptable. This is the ANSI method, and most often we use this one only. So we have seen that return, send back the control. So whenever we need to return some value, we need to write the return. But even if you don't write a return in a function, there is no problem. So return does what? When we reach return statement, it will transfer the control back to the calling program. And this return value will return certain values, which is in this case is the sum of three numbers. There can be n number of returns. There is no restriction in the number of returns which is present in your program. But the thing is, there can only be one return in the program which is going to be executed. For example, if you enter an alphabet, this is a function fun, you are entering alphabet, when this character is greater than or equal to 65 and less than 90 or equal to 90, we return this ch, otherwise we return ch plus 32. So either this condition will be true or this condition will be true. So only one return is going to be executed, though we have two returns here, but only one is going to be executed. So whenever control returns from the function, some value is definitely returned if you have a return value. It can be nothing or it can be some value which is given after the return. Okay, and these are all the return statement. That is, let me tell you here also that when you are returning some value, then only you can assign the value to any variable. This is how this line become valid. If you have no input parameters, no return, then you cannot assign it to some variable. This will not be true, or that will be wrong. The return can be anything of this sort. It can return some variable, it can return some number, it can return some floating point number, and then it can return nothing. Return after nothing, we have semicolon. That means it is returning nothing. So this is also problem. This is also not a problem. And if we want that a called function should not return any value, then you just don't write any return here and just give a void. If you don't want to return any value, you have to put a void in front of your function. A function can return only one value at a time. So this variable, two variable returning is not good. This is wrong. And returning say x comma 12, these are two values. One is your variable, other is number. So this is also not allowed. This is invalid. A function or a return, let me say a return, can return only one value, not more than that. If the value of the formal argument is changed in the called function, it is not going to be seen this function. That means if you are changing some value in any function, it will not be seen, the change value will not be seen in the calling function. This is called call by value. By default, C follows call by value. If you want the value to be changed, you have to go to call by reference. We'll talk about them separately after this. Let us take an example. A is 30, you are passing 30 here, and then this function will go take the control here. Now B is 60, you are passing A as 30, so B will get 30. But we have a local variable here, and this will be printed as 60. When you come again back, this function has no effect on A. So when you print A, only 30 will be printed. This is what I wanted to insist. Then only 60 and 30 is going to come. So even though the value of B is changed in function, it is not going to be changed in your main. It remains unchanged. For that, just understand that we are sending the photocopy or a copy of A, not exactly A. So A is 30, a copy of A, that is B, will be sent. This will be sent, and this has no effect. This will remain intact. What are the scope rules of a function? Scope means where the variable which you are defining or declaring are going to be used and where they will be visible. For instance, take this example. We have I equal to 20 here inside main. Now you want to display I. So 20 will go inside this. Now J will take value 20. Now you want to print K equal to 35. So when you print here, this K will be printed as 35 and J will be printed as 20. Okay. So when you assume that what will be printed Because if you take display I and you want this I to be given to this J, and you say that I is given to J, and now I want to print J, what will be printed? K will be printed here and J will be printed as the value you have given. Okay, but what I want to intend to say here is the scope of a variable is local to the function in which it is defined. Okay, it will not be available to the display function by default. You have to do certain tasks. Let me give you an example. First of all, let me tell you some calling convention. This calling convention, it indicates the order in which arguments are passed to the function when the function called is encountered. So the argument might be passed from left to right, or the argument function might be passed from right to left. So C language, it follows right to left. Just consider this function call ABCD. Okay, now when you just pass ABCD in whichever way you want to print, there will be no problem. It all will be okay. But when you try to print this line, what will be printed? As you see here, A is 1. So A is 1, so 1 will be printed. Plus plus A, you are incrementing A, so 2 will be printed. And now A plus plus, that is first this A plus plus, so again it is A plus plus only. So because this plus plus A, that is 2 is there, so A plus plus will be 3. So this is but obvious consideration that 1, 2, 3 will be printed. But this is not the case. This is wrong. 1, 2, 3 will not be printed. In fact, if you write this program, 3, 3, 1 will be printed. How? 1, 3, 3, sorry, 1, 3, 3, because we have given A as the first one. Okay. So how this will be printed? Let me show you. First of all, here itself I'll show you, because it is following the order from here to here. Okay. First of all, what will be there? First, this will be done. So 1 will come here. A plus plus means first A will be printed and then it will be incremented. So A will be 1. A has been incremented, so it will be 2. 2 will go here. First it will be incremented, then it will be shown. So it will be what? Because it has already become 2. And plus plus A will make it as 3. Now again A is there, so it has already become 3. So 3, 3, 1 will be printed. 3, 3, 1. I hope you got the idea. 3, 3, 1. So the ordering becomes very important, and the 3, 3, 1 has come because C's calling convention is from right to left. This you have to understand. This is very important. There is an issue. Just see this hash include conio.h. These are certain function calls, CLR, SCR, gotoc, and getch. These are all defined in conio. But how it is defined in conio, you can only use the way they are defined. You cannot just use by yourself that 10, 20 is there, you put 30 also. This is not there. There is a certain prototype which is being given and which is being defined in .h. That only you can use, right? So whatever is given in your .h, you can use like that, because this clear screen is given in your library file as it has void return type. In this gotoc, we can pass to integer and it returns void. In this getch, this is taking void, or it can take certain value, as we just saw getch. It is not taking any value, only it is doing something on getch. If you want to print also, getchar is getche. Getche is the option. It is returning int. So you have to be very, very aware that what is there in .h, this way only you can use. Just consider this function call I is 10, j is 20. So I is 10, j is 20. Now I and j will go here. How about this one? This %d will do what? There will be an error. How about this? I will be printed, say 10. How about j? What will be printed? There will be an first case, it will be, because it will be, the compilation will be done. I am saying that compilation has no problem. But when you run it, there will be an error or you can say not error, but some garbage value be printed in the first case, because this %d matches with ij. But how about this %d? It is not matching anything. That is why there will be an error. And same is the case with this. We have just 1% d and you are trying to print 2 values. So these are the problems that you need to understand. Advanced feature of functions. The C functions we have learned about the preliminaries. Let us go to the intricacies. First is the function declaration prototypes, then value and reference, and then recursion. We start with function declaration and prototype. So function declaration and prototype, whenever we declare a function or give a prototype, that means you are asking or you are telling the compiler that this is going to be somewhere. I have defined it somewhere. Prototype means this is the way it is going to be presented. That means these are the input values and these are the output values. Let us take an example. you want to find out the square of a and b. You are inputting the value a, you are passing it to the square function, and some b will be returned. This is your square function. So this square function says pass a float y, and this y will be x into x and y will be returned. So this will be the answer. But here is the case. The case is what? The case is when you are giving 1.5. 1.5 into 1.5 is not 2.0. 2.5 into 2.5 is not 6.0. In fact, it is 6.25. So wherever this 2.25 and 6.25 has gone, why we have just 0, 0? See, we have not given any return type here. By default, this return will return the value in integer. So when you have this 6.25 or 2.25 as the result, this will truncate the decimal because this is integer by default. And now when you put it and print it as %f, it will show with this .0000. So when you are not giving any return type, it is going to discard these two values, 0.25 and 0.65. Now if you want to really write a good function, you have to give a prototype. Say float values I am going to give, and float will be returned. Now you pass the value a in this square function. This float will come inside. You will have some y equal to x square, and now this float value will be returned, and this will be printed here as, because it gets collected in b, and you see you get exact value as 2.25 and 6.25 that was intended. This is how we have a function. This function has some input value, you have to give the type, and this is the return type. So this is called the function prototype. Function prototype says to the compiler that don't worry, whenever you see square out after this, I have some square. So don't give any error. So it is declaring the compiler that square is going to be, or we have described or defined the function. We can have, see, a situation like this. A function can be returning no value. It can only just be printing or doing that task which does not require any return of the value. For that you have to give a void. You have to define this function or give a prototype of this function like this, that it is not going anything in the response, and you just call this function without giving anything, because these only 4 lines will be printed. So if you call by value and call by reference. In C, the normal calling of function is done, or parameter passing is done by call by value. But there is one more thing which is called call by reference. This call by value and call by reference, whenever we talk about reference, we need to know the concept about the pointers. So what is the address? What is the reference? So let us know it, then we come back to this topic. An introduction to pointers. Pointers, they are nothing but addresses. A pointer points to an address. So whenever we are talking about pointer, we are dealing with address. Pointer notation, just consider int I equal to 3. So whenever you do this declaration, what happens? There will be in memory. Now we are dealing with memory. Right now we are actually going to the hardware. So in that hardware or that memory, you will have a location where 3 will be placed, and 3 is an integer. This location will be known by the name I, or will associate this name I with this memory location, and will store a 3 here. This is a memory space which is stored for the integer value. Just assume that this is a 16-bit compiler, so we have a 2 byte of integer memory. This is the actual formulation. This is the location name. This is where I, or the value of I is placed, which is 3, and this is the address of this location. When you actually find it, it will be in hexadecimal value. So this is your address. Please understand, this integer variable and this address, they are completely different. This is a memory address, and in this location the value which is stored is 3. So whenever we are talking about pointer, we are talking about this address. We are talking about this address. So what this program is going to give is I is equal to 3. Now when you just print the value of I, it will give you 3. Here it will give you 3. How about this? When you place an ampersand before I, this ampersand says address of I. What it says? Address of I. I is the variable. When you put an ampersand, this says address of I. So when you want to print the address, you have to give an unsigned integer. That is why we have used %u. So this is the address of I which will be shown, and this is the normal value which is the value of I. So this ampersand is address of, and %u is specifically to cater to what is going to be printed, that is the address. So we have one more operator which you will deal normally with pointer. This star means value at this address. If I say ampersand I, this is address. Now if I say value at this address, that will be 3. I hope you got the idea. And ampersand I gives you the address. I am saying star, I am putting a star. This star means value at this address. So this is the address, value at this address is what? 3. Now see this program. This is I equal to 3. This second line will give you simply I. That is 3. There is no problem as such, but this is I, this is 3. Let us take the address, for instance, as 65524. When you print, it will not be 65524. It will be anything. But let us take for this example 65524. When you print the address of I, it will be this. So this will be printed. But when you say this is address of I, when you say the value at this address, so this address, what is the value at this address? It is 3. So 3 will be printed. This is 3. So this is the value at this address. Now one more thing you can do. This j is equal to ampersand I. J is not an ordinary variable. J cannot be just int j. It cannot be like that. Because it is taking the address. And this address is different and entirely different from the value. So it has to be a star j. It has to be a star j. What is this j? J is keeping the address of I. What is I? 3. What is address of I? 65524. What is the address of I when it is assigned to j? So j will keep the value of address of I, and address of I is 65524. This will be kept here. Now this j may have some other address. Okay. So this is how you deal. But when this j is going to take value of I, address of I, this j cannot be normal value. It has to be a pointer. Only pointer or pointer variable can take the address. So this is the indirection operator. You can say it as a star or a pointer of notion. This int star j. Now when you put a star in front of int, you say now this is a pointer variable, this is a address variable. It will only be able to keep the address, not the normal value. So let us see, or you can say summarize what we have just learned. This is I equal to 3. Now this is 3I. It has some address 65524. Now you are assigning the address of I to j. So j will contain what? Say 65524 will be there, because the address of I is given to j, and j has some other address 65522. Say I am just taking in some example. Now when you put try to print the address of I, which is the address of I. What is the address of I? This one. So 65524. How about j? J is the simple. J is the address of I. So j value is 65524 again. Now address of j is what? This one. 65522. What is j? J holds this value 65524. What is I? I is simply 3. What is the value at address I? What is the address of I? This. What is the value at this? 3. What is star j? What is star j? Star j is nothing but the value which is which is the value at j. So j has this. What is the value at this? 3. So this will be the result. I hope you got the idea. So this is how it is being read. All these things has to be because this ampersand and star, these are symbols and they create confusion. Because many people say pointer is confusing. No, only these symbols are confusing. Once you know the concept, they are very easy. So int star alpha means now this star alpha, this alpha is now this is a pointer variable which will have the address of some integer value. This will have address of some character value. This will have address of some float value. Okay. This means simply that this s will keep the address of some float value. So now we will take one more result. This is star of j, or say k. Here k, there is k, so let us take it as k. So this gives you the value at k, So k is address. Now value at k. Now this will give you the value of this address. Means first address. Then we have this again one address. So that will be the value of address of address. So this is address of k. I hope you got the idea. Let me give you an example. If I have a diagram, say let me show you. Yeah. This is this. So I is 3. Now it has some address 65524. Now j ampersand of I is given to j. Means address of I is given to j. So the address of I will go to j. Now j has its own address. Now when you assign address of j to say k, the address of this will go here. K may have some other address. So when you say star j, that will give you 3. When you say star of k, that will give you 65524. When you say star of k, that will give you the value here. Star k gives you the value which is contained by j. Star k will give you the value which is kept here. So it will give you. Now let us see the program. This is our program. We have j, we have k, but this is j. A pointer, this is pointer to point. I is keeping the address, j is keeping the address of I, k is keeping the address of k. So when you print the address of I, that will be if you say that is 65524, it will come. What is the address of I, J? Again 65524. What is the value which is kept by K, which is the address of J? So that will be 65522, say. Okay, 6552. This. Now what? 65524. Let me go back. Star K, as we just say, star K is what? See, star K will give you what? This one, 65524. The value at its address. So 65524. Okay, this is okay. Now address of J is what? Address of J will be 6552. This K will simply keep the value, that is 65522, and address of, that is ampersand of K will be 65520, the address of K. And what is the J? J will have 65524 because it contains the address of I. What is the this one? The value of K. K will be simply having the value of 65522, that is the address of J. Then I, the I is simply 3. Now the address of I, the value at address of I will again 3. The value at J, because J is 65524, the value is 3. The star of K, as I just suggested, will give you 3. I hope you got the idea. These are all the indirections. So this is how this program goes. Call by value, call by reference. So there are two ways. With the help of pointers, there are two ways by which you can pass the value to function. This is the default way in which we send the value to the function, which is call by value. This is call by reference. So arguments are passed by sending the value or sending the address. When you pass the value's copy only goes, not the actual value. But when you pass the address, you are actually pointing to the location of that address. So actual value is being interpreted, analyzed and changed. I hope you got the idea. Call by value means you are sending the copy. Address, when you are sending, you are not sending the copy. Say I3. When you are sending I by pass by value, you are just making some copy of I and you are sending this. You are not doing anything on this memory location. You are having some more memory location on this. This is going to be worked out. But when you pass the address of I, that means you are not going for any other memory location. You want to change this memory location value. So if I send address of I, and now I change I plus 1, this will be 4. Let us take an example. A is 10, B is 20, and now this swapping is being done. Swapping is 10 and 20. How swapping will be done? Say this is 10 and this is 20. So we take a temporary variable. First we assign this 10 to t, means x to t. This has been done here. Then we assign y to x. So 20 goes here. 10 has come already here. 20 goes here. So y to x. Then we assign t to y. That is 10 goes here. 20 has already come here. So this will be 20. This will be 10. T to y. When you print it, it will be, the value will be changed. This will be 20. This will be 10. But when we print here inside the function, this value will be swapped 20, 10. But when we come out of this function and we print here, we only see 10, 20. This A will be 10. This B will be 20. So the value will not be swapped, because we are sending the value call by value. So we are just sending the copies of the A and B to X and Y. We are not sending the actual value. So when you see inside function, it will be swapped. When you come outside, it will not be swapped. The value will not keep its value. Why? How to do it? For that, we need call by reference. So let us see the same thing with call by reference, because we don't want to send the copy here. We want the actual values to be changed. The locations, the memory locations, we need those memory locations to be changed. So now we have A and 10. We say send A and B. We send address of A and address of B. We send address of A and address of B. So when we are sending the address, we cannot take the value just like that. We have to take the address in pointer value. That is why we have taken star x and star y. Now simply because star x is nothing but the value at x. So this will only be simply a variable. Okay. So we take a temporary variable, do the same stuff, same thing we have done. And now the memory locations, which is pointed by A and B, which is again pointed by X and Y. So this is X, this is Y. X is pointing to A is pointing to this location, B is pointing to this location, Y is also pointing to this location. So when you do 10, 20, and when you swap, 20 comes here, 10 goes here. So this memory location now will be changed. This same memory location. So either you print here or you print here. Don't worry. It will be same at any point. Here printing, the values will be changed. They will be swapped because you're sending the address location. Okay. So this is how we generally deal with call by reference when you want to change the actual values which are being sent, or when you don't want your initial values to be changed by any chance. you do it by call by value. Let us take one more example. Now this is area and parameter. Now you are sending the address of area and address of parameter. So you have area, say let me take it as A. This is parameter. You are saying I am sending you the address of A and address of P. Whatever change is being done, do it here only. So now the area and parameter has been sent here. The radius is also sent. When the area will be computed, it will be kept here. When the parameter will be computed, it will be kept here. When you print A and P either here or outside the function, means coming here, you will always see area and parameter the same value. There will be no change. So even if you put any circle radius, you will see the proper values. So this is how we have done. But there is one more thing which we wanted to share. As we indicated earlier, that a function can only return one value. Okay, agreed. One function can return only one value. Here a function is returning two values at the same time, and this is only possible when we are using the pointers. So if you want to return more than one value from the function, then you see we are dealing with pointers. So you can have multiple return if you are dealing with pointers. So what we conclude from this program, if we don't want our actual program to get changed, we pass the argument by value. We want actual value to be changed, we pass the actual argument by reference. If you want the function to return more than one value, we use call by reference. Recursion. What is recursion? When a function calling itself is recursion. So it is possible in C that the function can call itself or themselves. A function can be called recursive if the statement within the body of a function calls the same function. We also call it sometimes as circular definition. Recursion is therefore the process of defining something in terms of itself, calling itself. Let us take an example, an intuitive example. We want to find out the factorial of say 5. What will be the value? It is equal to 5 into factorial 4. This is 5 into this factorial 4 is 4 into factorial 3. So to find the factorial of 5, we have to find out the value of 4, factorial 4. To find out the factorial 4, we have to find out the factorial 3. So every time we are finding out the factorial till the time we reach 1. So this is the ideal situation to use the recursion. Let us take an example. What we are trying to do here is, we can, without the recursion, how we can implement this particular example. We have a number, we enter this in a number and we pass it to this function, and the result return will be taken in fact. So after this, the function will be executed. So we are passing this A inside x. This we start with f equal to 1 and I till that x, till we reach 1. That is from that number say 5 till we reach 1. We subtract the number, and every time we take the multiplication of this 5, say first number and then 4, and we keep them in f. Again this is kept, so we multiply 3. We keep this again in f, and we do it again and again till we reach 1. So ultimately the result will be the factorial. This is way how we compute the factorial without recursion. So for 3, factorial 3 is nothing but 3 into 2 into 1. So it will be 6. But if we see this program very carefully, this is ideal. This is an ideal situation for the recursion. So how does this recursion take place? Again we enter the number, we pass it to the function, and then we'll print, but we have to concentrate on this function REC. What it does is, whenever we pass any value, we ought to have, in recursion, we always have some terminating condition. That is, if we say want to find factorial of 3, so 3 is being passed, the 3 is not equal to 1, so we don't return 1. Otherwise, we go for f is equal to x into, again, this is the same function. So what is going on here is, first of all, this f will have, this is x, so this will be 3, and then again this will be called REC. What will be the value? X minus 1, so REC 2. But this has to be called again, so this function has to be called again. This has already been done, 3 will remain here, and this function will call this again. So what will be the value? Now 2 will go inside, 2 is again not equal to 1, so we don't return 1. We again go here. So this 3 into this REC 2 will return what? This one. So this will be 2 into REC recursion, 2 minus 1, that is 1. Again we go back because this is being called. Now this has called this one. Now this is going to call another one. This is 1 minus 1, okay. So 1 minus 1 is simply because 1 is going to be passed. So 1 will come here and says, okay, now we have got 1, it will not go here. It will return simply 1. So 3 into 2, now this will return 1. This was already there. This 2 has come from the second iteration, and this 1 has come from the third iteration. So ultimately you get the 3 into 2 into 1, that is the value of factorial. This is the result. So how does it take place? What is the thing which is going on? There is a terminating condition and there is a return condition. Every time we get a value, we don't reach to that terminating condition, but we go to this condition till the time we reach x equal to 1. So every time when this recursion x into recursion x minus 1 is called, this will remain intact. So this will be called and this will call it again itself till the time it reaches 1. I'll show you this with a diagram. This will be, if we want to find out the recursion of say 5 is the value which we give here. This will return 5 into recursion of 4, 5 minus 1. Then this recursion of 4 will give you 4 into recursion 3. Now this recursion 3 will give you 3 into recursion 2. Now this recursion 2 will give you this one, and this final recursion 1 will give you the terminating condition, that is 1. Again, what we are trying to do here is, we are calling the function by itself till we reach the terminating condition, and we have to see which is the best problem so that we can go for the recursion. So every time we have to go to certain limit or certain place where the recursion has to stop. I'll show you what the text I have just shown you in this figure. What is going on here is, we is calling this recursion. This is int x. X is being passed, and this, if x is equal to 1, we are trying to find out the factorial. If x is equal to 1, we return 1. Otherwise, we say x into recursion x minus 1. Now what is happening here is, this recursion x minus 1, this will be calling this again. So it will be calling rec. Now x will be now x minus 1. We again go inside. If x is equal to 1, 1. Otherwise, we return this. So for this whole will be returned where x will be equal to x minus 1. Now again this rec x minus 1, this is going to call itself. Again this will be returned till the time we reaches this condition if x equal to 1. But how does it work? Recursion is closely related with the stack. Stack is that area, you can say the data structure. For example, we have data structure in various forms. You can have array, linked list, binary tree. So the stack is a data structure. Basically, data structure is nothing but a different way of organizing the data. So compiler here uses data structure called stack for implementing the recursive function call. The stack is just like if you go to a party and you see a stack of plate on the table. On this table, you can only place the plate on the top, and you can remove the plate from the top only. That means if any data structure is such that the insertion and removal is only possible at one point, this is called the stack. So this is LIFO, last in first out. So when we put something on the stack, we say that we are pushing. When we take something out of the cache, top value out of the stack, we call that we are popping it out. Say if this is a equal to 5 and b equal to 2, we have taken c. We want to add a and b. How does it goes into the stack? Because we are printing the value c. So in this function, this a goes to I, b goes to j. That means 5 and 2 are being sent. So what will happen here is, first of all, 5 will be kept, 2 will be kept here. Then we go to this address, means some function has some address, so say some XX address. And these 5 and 2, the sum will be returned, so sum will be popped out. Sum will be equal to 5 plus 2, that is, you get 7. So this is how it is done. I'll show you with a diagram, that will be better to understand. This is an empty stack. A copy of B will go, copy of A will go, 5 and 2. When the call to function is first being met. So the address of printf, it can be anything, say some xxxx. Here the address of printf will be there, but the sum after that will be 5 plus 2. It will be kept on the top of the stack. Now this top of the stack value will be taken out, and then this will be the actual result. This is before transferring control to function. This is on returning control from function. So this is how it is done. We also have something called as CDECL. See, declaration calling convention, when this happens. So we are putting values on the stack, and we are taking the top off to find out the actual value, right? There are certain more things how to push stack from left to right or right to left. So the standard calling convention here is right to left. We'll always follow right to left. So during say some function f, the first value of b is pushed on the stack, then a is pushed because we followed the right to left order. Otherwise, the way I showed you, it was first A, then B. But we only follow right to left. So just follow this. So this is how it is going on. Now, how to add functions to the library? We already have a library, C library. Now, you want to make some function and you want to add it into the library. So you want to enrich that library. How to do it? We will be specifically talking about the Turbo C++, C++. In this, we already have tlib.exe. This is Turbo library. This already is there. So we can add the function or the content which we have made in the actual library of C. How it is possible? First is, just write a function definition factorial, and it has to be foolproof. That means complete by itself. Like you can make a fact.c, and in this, what you can give, this is int factorial and int num, and here you can start with I f equal to 1. You can give some I 1 to num and f equal to f into I. This is your factorial you have written in fact.c. We have known about this, so we will not discuss this right now. Just compile this fact.c. When you have compiled this, a new file which is called as fact.obj will be created. This is actually the compiled code in machine language. Now how you have to add, I am specifically talking about a compiler, so it can be different for others. You have to add the function to the library by just issuing that command, because we already have plib.exe. So this math.lib you want to add the factorial in math.lib, math.h which you call. So math.lib you want to call. So what you will do here is math.lib plus c colon. If you have placed it in c colon, I'm just taking an example. It can be anywhere. You have to give the path. So c colon slash fact.obj. This will be added to math.lib. This is what you have to do. Only this one. Okay. And now once this has been done, go to the fact.h, because this will be available to you. Math.lib will not be available to you. Okay. Only fact, the header files are open to you. You can see it. Now go to the factorial, the fact.h, declare a prototype of this factorial function in the header file by making fact.h. The file should be included whenever you want to call that function. And to use the function inside the library, how you are going to do this? Just say hash include the path c colon. Please mark we are using double slash here, fact.h. Now you can easily call this function and just compile and execute the program. Everything will be fine. So if you want to delete the existing function from the present library, you have to use this minus sign. This is minus which you have to use. Now instead of modifying the existing library, the better way is to create your own library. Just assume that you have made function like factorial, prime and Fibonacci, and this name suggests that this factorial calculates the factorial value, prime number, and Fibonacci series the Fibonacci terms for n term and first n term whenever n is passed. So how to create your own library? First we have seen how to put your functions inside any library or the math.library which is already being given to you. Now you want to make your library by itself. So how we are going to go about that? First just define the functions, only functions, no main will be there, only functions factorial, prime, Fibonacci in a file, say myfuncs.c. So you can name it by yours. Do not define any main. Just create a file myfunc, same name with .h, and declare the prototypes of these three. In this only prototype will be there, nothing else. In .h only prototype will be there. And when you have, when we're talking about this Turbo C, we have options menu. Select the menu item application, and if you find the dialog, the pop-up says library. Just select OK. Compile the program. You will create myfuncs.lib. This .c will be converted, or this .h and .c combined converted into myfuncs.lib. That's it. That's what you have to do. This will do the job. Now, how you are going to use it? Just create a file, say sample.c, and type this code. Now, this in the hash include you have given myfuncs.h. This is what you have given here, and you have used factorial, prime, and Fibonacci all by just making your own library file, right? So this is how this myfuncs.h needs to be included in your sample.c. This is how, and that is how you can, and this has to have a specific path. This will make your own library. After that, you can go to the project menu, select the open project menu, and give the name, say sample.project. This from the project, just select add item, and then if you have a file dialog, select the file sample.c and select add. And also you can add the file this myfuncs.lib in the same manner and just say done. So this is for Turbo C and C++ compiler. If you use VC++, the things will remain same, only the steps will, and just compile and execute the project. Let us summarize what we have seen. Just avoid repetition of code and the bulkiness of the program. And just to avoid this repetition of code, and if you don't want any bulky or bloated program, just isolate your program in terms of function. Function declaration, it specifies what is the return type of the function and the type of parameter it is going to accept. Function definition defines the body of the function. Variable declared in a function, they are not available to other function in a program. So there won't be any clash even if you give the same name. So they can have similar name. Pointers are a variable which hold addresses of other variables. And the function can be called in two ways, either by value or either by reference. And call by value is the default in C. The pointers can be used to make function return more than one value simultaneously. Recursion is calling a function itself. Adding too many functions and calling them frequently will slow down your program execution. This you have to understand. So this is all about this chapter, function and pointer. Thank you so much and take care of yourself.